So the term AI or artificial intelligence gets used an awful lot today. Even if you're using a streaming service, they'll say the recommendations of what movie you should watch next are created by AI, or a music streaming service, the songs that it's going to create for you in a playlist are generated by AI, and so on. And then of course it goes up to much bigger and grander things. Now, with the terminology AI comes a whole bunch of other phrases and words like large language model or training or inference or hallucination. There's a whole bunch of terms. And in this video, what I want to do is give you a guide to those terms that can help you navigate the choppy waters of what is modern artificial intelligence. So if you want to find out more, please let me explain. Now, the first term we need to look at, of course, is the term artificial intelligence. Historically, it meant human level intelligence that was achieved artificially with some kind of machine. But over the years, that's now been watered down. It's more of a marketing term nowadays. And as I said, it gets used from everything from, your shopping list on a big e-commerce site to something that can play chess, or to something that can understand your voice. Anything that shows any kind of intelligence gets called artificial intelligence, or characteristics of intelligence, not really even intelligence, but characteristics of intelligence gets called artificial intelligence. And because of that, there's now other terms that we're going to look at that help us to distinguish between the marketing term of AI and actual real descriptions of technology, or aspirations of where technology wants to go, or sometimes even philosophical ideas about the use of technology. Now, the next phrase to look at is machine learning. Now, machine learning is a subcategory of artificial intelligence and describes any system where a machine is able to take in some data, some experience, learn from it, and then give a different result, take a different action, do a different thing because of what it's learned. And the simplest example of nowadays would be, let's say you have an algorithm, a system that you're able to feed pictures of cats to, thousands and thousands of pictures of cats. The system learns what a cat looks like from all those different pictures. You then show it a picture of a cat and a dog, and you ask it which one is a cat, which one is a dog, and it should be able to pick out the cat because it has learned from the experience of seeing all those thousands of pictures of cats before. Now, when we talk about artificial intelligence, for sure, any artificial intelligence system today and in the future will have a large machine learning component to it, and we'll talk more about its role in other aspects as we go along. Now, we talked about how you have to show the machine learning system thousands and thousands of pictures, and that's what's called the training phase. So when you have machine learning and therefore artificial intelligence, you need a training phase where it is fed lots and lots of data, whether that be about flowers, whether that be about cats, whether that be about the entire internet that just gets put into the machine learning algorithm. There is a training phase. Now, training is a very complicated and long phase. Today's modern big AI systems, when we think about ChatGPT and so on, they cost millions of dollars to go through that training phase. If they were trained on just a single computer with one GPU in it, then it would take hundreds of years to achieve that training. Now, nowadays, of course, it's done in parallel, so it's done in a matter of months and weeks. However, it's still a huge amount of computing resources, a huge amount of money, huge amount of electricity, huge amount of hardware. So training is a serious part of the machine learning technology. Now, once you've gone through the training phase, you then move to the inference stage, and that's where us normal people get involved when we use things like OpenAI, ChatGPT. When we talk to our home assistants, then we're benefiting during the inference phase. We say something, it understands our voice. We show it a picture of a cat, it knows what the cat is. We ask it a question, what is the capital of England, and it gives you the answer from what it's learned beforehand. Now, the inference stage takes way less computing power than the training stage, so you can even run it locally. So I've got lots of videos here on this channel showing you, for example, how you can run a large language model, and we'll talk about those in a minute, on your laptop or on your PC. And I've also got videos here about whether you need an NPU, a neural processing unit, to run machine learning. Do you need an NPU inside your PC? Can you not run it on a CPU, or can you not run it on a GPU? I cover all that in that video. So inference is much less intensive than training. Now, as I said at the beginning, artificial intelligence was historically human level intelligence achieved artificially, but that term has now been diluted. So to replace that original definition, we now have what's called artificial general intelligence. And so this is basically anything that you kind of see in sci-fi movies, any robot, any kind of android, any kind of machine that can speak and make decisions and all that. That's more towards what we would have called artificial intelligence, and now we call artificial general intelligence. And it's more than just machine learning, because in there you have to have decision making, you have to be able to do planning, you have to be able to see the world in a greater context, understand the results of actions that might take place beyond just some kind of data set that's been learned. So artificial general intelligence is a whole new area that of course we've not got yet at all. We're nowhere near at the moment artificial general intelligence. Of course, it's being worked on. And that in itself spawns further definitions. So of course, when we start talking about intelligence, we have to start talking about other things like the mind, emotional intelligence, self-awareness, sentience. There's a whole bunch of words that we can look at from both a philosophical point of view, from a psychological point of view, that talk about the attributes and the characteristics of intelligence. Free will would be another interesting one. And so there is kind of now this split on what kind of artificial intelligence are we trying to create. One, which I like to call weak artificial general intelligence, is a system that's able to mimic intelligence, but it's still just an algorithm that's running, doing what it's being taught to do, and it never actually achieves consciousness. There's never a mind, there's never sentience, that kind of stuff. We're not talking about an artificial human, we're talking about mimicking that level of intelligence based on algorithms and computing power. And then there's another aspect which people are thinking is possible. I personally don't think it's possible, but people think it's possible, which would be strong artificial general intelligence, which is basically an artificial mind. So human level of intelligence, sentience, self-awareness, consciousness, morality. There's a whole bunch of words that exist in an artificial mind rather than a biological mind. And then there's also artificial super intelligence. The idea being that if we're able to create human level artificial intelligence, whether that's weak or strong, then why can't we create something that's 2 human powerful, or the same as 10 humans, or a super intelligence? And so this is an artificial intelligence system that is way more capable than we are. And then this spawns a whole bunch of different possibilities and problems. Possibilities would be something that would take 10 of the greatest minds years to research in physics or in biology or in whatever system, whatever science it is that you're interested in. That could now happen in a matter of days, weeks, moments, because the artificial super intelligence is dealing with that subject matter. And then of course there are the problems of what does that mean for humanity itself? Can an artificial super intelligence get to the point, Skynet basically, can we get to the point where humans are considered no longer needed because the world is now run by artificial superintelligence? Now, the next term we need to look at is generative AI. Now, traditionally, machine learning systems have been very good at classification and recognition. Is this a cat? Yes, it's a cat. Can you understand this human voice? Turn that into text? Yes, I can do that recognition. But generative AI goes to the next step where the machine learning model is able to generate text, generate images, generate music based on an input. So rather than just recognition or classification, it's actually in the phase of generating something. And we're seeing that today with all the image creators that exist, all the large language models that exist, and we'll talk more about those again in a minute. So this is something that really has been revolutionary in the last little while and has really moved forward machine learning and artificial intelligence in a whole new direction. Now, one of the fundamental building blocks of all of this technology is a thing called a neural network. Now, neural networks have been around for decades, and they're kind of based on the idea of how we think the brain works. So there are neurons that have connections to other neurons. Now, in a neural network, you have a network of neurons that are interconnected. And basically, by stimulating or putting data into the input layer of the neural network, it will process it through various hidden layers, and then at the output layer, it will give you an answer. And so back to our cat example, the input would be an image of a cat over many, many neurons. It would go through various layers of neurons that are interconnected, and then basically an output would be, yes, it's a cat, no, it's not a cat. Or if you were doing object recognition, it would say, what is it? And it would recognize a cat and a dog and a jellyfish, and it would give you the answer. Now, during the training phase, you start with this network, and it's just random data. And then as you keep giving it more and more information during the training phase, it has a feedback mechanism which is able to change the weights of the connections between the different neurons. And so it's able to learn what the input means and how that should correspond to a different output. And basically, you say, this is a cat, you put it through, and you say, so we expect the result here to be cat. And then you keep doing that until it builds up internally this structure. Now, the amazing thing about this is because it contains so many of these connections that's far beyond what we would be able to produce just procedurally. Someone writing a program, someone guessing some of the weights, now you can do that for a very simple example. Now, I've got a video here on this channel about how you can do Celsius to Fahrenheit conversion using a neural network, and you can see the weights that get developed during that, and they are very similar to actually the mathematical operation that you need to convert between Celsius and Fahrenheit. Check out that video if that interests you. But of course, when we're dealing with much, much larger things, then of course that would be impossible to set by hand, but it is possible to set via training. Now, one special type of neural network is the transformer network, and that's what the T stands for. When you have ChatGPT, it's the transformer, and that's a particular type of network that has enabled the birth of large language models and so on, because it has a particular technique to enable the relationship and the context between the data to be established. And it came from a very famous paper called Attention is All You Need. Now, we were talking about the different connections between a neural network. That is technically called the parameters. There are weights and there are biases, which are part of a neural network, how those connections are formed. And you measure the size of a neural network by the number of parameters that it has. And neural networks can have a very low number of parameters, 20, 30, I mean, very, very small. They don't achieve very much. And you can measure it up into the billions, and we'll give you some more examples of those in a minute. Now, when you take neural networks, when you take transformers, and when you take training that trained a very large neural network, we then have the birth of what we today called large language models, LLM, ChatGPT, Claude, and all the others, Llama and Grok, and all the others that exist today. These are large language models. And basically, large language models are trained on a huge amount of text. I'm talking about basically the entire internet. And then you can then ask it questions, and it's generative AI, so it gives you a result. And the way it works is by prediction. So if you said to an LLM, the king lives in Buckingham, and then let it complete, it would put the word palace there, because it knows that the word sky or tree or car is not the right word to come there. It makes no sense according to its training data. So it knows that Buckingham Palace is the right answer. Now you then multiply up that kind of idea by a huge factor, and you can now say, what's the capital of a certain country, and it'll give it to you. Or I write a program to do this, and it will give it to you, because it has this huge amount of data, and it's got pathways formed inside of it. And there's a critical mass here. There's a critical mass where those formed pathways, there seems to be a moment where something special happens. And I don't think we really understand what that is, but there is a special moment where the context is so well defined that you can ask an LLM a question just like you'd ask a person, and it will give you a result, and that result seems to be very, very impressive. However, it is only based on prediction. There's no thought, no consciousness, no context in terms of self-awareness. There's no, kind of mind functioning here. It's a predictive model that gives good answers because the model is so huge. Which then leads on to our next word, which is hallucinations. Why is it that you can ask an LLM to create you a legal paper to defend a certain case, and then it will produce a very nice looking legal document, and at the bottom it will list all the cases that support the argument, and they're all just fabrications. Those cases don't exist. And that's because when it's trying to create a legal document like that, it knows that at the bottom there has to be a list of cases, so-and-so versus so-and-so, the court versus so-and-so, the state versus so-and-so, in whatever year. And it knows the format of those. They have to have a title, something versus something in a year, and it knows that format, so it just starts to generate them. Now, its predictive model just starts to generate them randomly, because it just knows what the format should be, and out they come. And that's just one example. So hallucination is often a big problem, because it's basically just using the data that it's got to predict what should come out next. So of course the classic case we had recently was, how do you stop the cheese slipping off your pizza? And one of Google's search results that was enhanced by AI, by an LLM, basically said, well, you should use super glue. Glue it to your pizza, because someone wrote that in a Reddit post somewhere, that got sucked into the system, and it thought, right, that's the real answer, because it doesn't know what a pizza is, it doesn't know what cheese is, it doesn't have a concept that you can't put glue on a pizza, because it's just using a predictive model. So that's hallucination, and it's a big problem, and I personally don't think it can ever be fixed. The nature of an LLM means that this can never be fixed. That doesn't mean that there aren't other artificial intelligent machine learning systems that we're going to develop, but the fundamental design of an LLM means that this is always going to be a problem. It's going to have to be controlled by something else or part of something bigger if we want to go beyond that. Now, we talked about parameters, just to mention that, for example, Llama 3.1, which was released by Meta, Facebook, very recently, has 405 billion parameters. So it's measured in the hundreds of billions of parameters, connections between all of those neurons. Now you can get much, much smaller LLMs. You can get some that are 2 billion parameters, 7 billion parameters, 13 billion parameters, 40 billion parameters, and so on. And when you're running them on your PC or on your smartphone locally, then you'd use one that only has a few billion parameters, 7 billion, 13 maybe, on a smartphone 2 billion maybe. But when you run these big ones that people are connecting to into the cloud, then that's got hundreds of billions of parameters. Now, two more quick definitions to look at. One is a diffusion model. That's what we use when you want to create images. And diffusion models basically are trained on images with labels that go with them, and then they're shown that same image as more and more noise is added to it, so that it gets less and less clear, and it just ends up being random dots on the screen. And it's shown that process again in the training phase, so that when you do the opposite, if you say to it, here's a load of noise, how would you turn that into a dancing frog playing a violin? Then what it basically does is it changes a little bit to say, well, we should change a few things here. And then the next attempt, you say, we should change a few things here. And after you do that, after many attempts, you end up with a picture of what you asked it for. So it gets trained in one direction, and then the diffusion takes it away and goes from noise back to the image. And that's basically how those systems work. And the final thing today is RAG, Retrieval Augmented Generation. So generation comes back to large language models, a generative AI, something's being created, but you augment it, you help it by adding in some other data. So you retrieve data from the internet, for example, or from a local database that's proprietary to whatever job you're trying to achieve, whatever task you're trying to achieve. You give that to the LMM saying, given all this data here, what would you say about something? And then it takes that data plus its own large language model data and then produces a result. So you could give it 5 different web pages about a particular topic, and then you could say, create me a summary of all of those, and it will take all that information. Or you could have, data about your customers and about their satisfaction that no one else has. It's not on the internet, it's private data. You take that data and then you add that to the request that you're giving the LLM, and then it can give you a result based on your data. So you can say, looking at all these customer reviews, are our customers happy or sad? And then it can look at all that and give you such retrieval augmented generation. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this journey through all the different terminology associated with machine learning, artificial intelligence, and so on. If you did enjoy it, please do give it a thumbs up. And if you like these kind of videos, then why not stick around by subscribing to the channel? Okay, that's it. I'll see you in the next one.